Alright, for number 13, we're factoring this trinomial. So let's go down our list. Method number 1, is there a GCF? Do they have any number that I could divide all three by, or do they share any variables? Well, 5, 35, and 60 can be divided by 5, so far I'm using method number 1. So if I factor out of 5, I'd be left with 5 times what gives me 5x squared and x squared. I would bring down the plus sign. 5 times what would give me 35x, that would be a 7x. Bring down the plus sign, and then 5 times what would give me 60, that would be 12. So from here, whatever's left in your parentheses, if that can still be factored by any other method, you need to factor it completely. So we're only down to 2 methods here, method number 2 or 3. For method number 2, it has to be a binomial, and what's left inside is a trinomial, so it can't be method number 2. Method number 3, can this be factored? Well, in order for this to be factored, we would have to find factors of 12. We would be adding the numbers in our list because that's a plus sign, and they need to add to 7. So 1 times 12, 2 times 6, if I add those, doesn't give me 7. 3 times 4, well, that does give me 7. And do we need to modify the signs at all on the 3 and the 4 to get a total of positive 7? Both need to be positive, so this can still be factored. So we're actually using method number 1 and 3. So the 5 goes straight down, and for method number 3, you always open up 2 binomials. X squared would split as x times x, and then we already found our 2 factors here, positive 3 and positive 4. Again, you can always check your factored form by distributing or applying box method.